We will now look at analyzing time-related calculated data. Now, Debrief is capable of producing analysis products far beyond the traditional graphical track plots. All it needs is the data. The most obvious derived products are the analysis plots, graphs showing time versus either a recorded data value or a calculation based on a specific set of data values. In this tutorial, we will look at how to do just that. And to be able to analyze the data correctly, we first need to tell Debrief what information is required, such as the time period we want plotted, which participants to plot data for, what type of data to plot, and which is the primary track if we want relative calculations. But before we do that, as always, we need the data. So if the navigator view is not open, open it and then open the sample.dpf file if you closed it at the end of the last exercise. And then click on the Fit to Window button. We don't need the bookmarks view for this particular exercise, so I'm going to close that on my screen. And then I hit Fit to Window just to make sure. Your time controller should still be open, but if it isn't, click on Windows Show View Time Controller. And then we're going to select the time period required. So we're going to adjust the start and the end markers to select the period 0800 to 1100. So we can drag the start mark, and remember, if you hold down the Shift key, it'll snap to the hour points. And then 1100. If I get near to the point, if I hold down the Control key and then double click, there you go, I can move it, but I didn't get close enough. Just going to do it one more, and there we go. And that's it. Click away, and then it selects that particular time period. Now we need the outline view open as always, and then in the outline view, click on Track Collingwood to select it, hold down the Control key, then click on Track Nelson. We're now going to open what is called an XY plot. Right click on the selected tracks, and then you'll see View XY Plot. Then you get the View Time Variable Plot dialog, and we're interested in range. So select range, click on OK. And as always when working with tracks, we need to designate which is the primary track. And we're going to select Collingwood. Click on OK. Then as you can see at the bottom of my plot editor, I get the Collingwood range v time plot graph. Now I'm just going to make that slightly larger so we can see what's going on here. And here we go at 0800. If I move my mouse over the end there, get a tooltip which tells me the value was 7,567.387 yards at the start. Now to navigate around this plot area, to make it more precise, we can zoom in or out. If I want to zoom in, I drag top left to bottom right, and that's what happens. And then I can do it again, and I can do it again, and I can do it again, and then we can see now that that's fairly precise. If I want to zoom out, drag bottom right to top left. You only have to do it once, and then you'll see the whole graph. The other thing you can do is Fit to Window, so I'll zoom in on the endpoint and see how close they are at 1100 hours, and there we go, 286.054 yards. So if I move that to 1100, we can see the vessel positions on the plot editor. There, that's how close they are. And this range v time plot is fully customizable, so you can experiment with the other commands present on the view toolbar, as seen here. You can even configure and customize the graph to use your preferred font and titles if you require. And you click on the Change the Editable Properties. And as always, in the Properties view, we can now change the axis font, the tick fonts, etc. I'm going to change the title text. So I double click on it to select it. Collingwood v Nelson. Calculated range. You don't press the enter button, you just click away, and then as you can see in the time plot itself, my title has now changed. As you've seen, you can perform a number of functions in the range versus time plot graph, but there is another way to measure range and bearing, and that's by using the Measure Range Bearing button on the main toolbar. And using this, you don't have to go to the trouble of designating primary and secondary tracks, and this option also allows you to measure the range and bearing between any 2 points on the plot editor. So for example, if I click on the Fit to Window button, I'll just move the Collingwood v Nelson calculated range down, if I click on the bottom left corner of no-go delta, and then I drag it down to the top left corner of the white other line, and because I'm zoomed out quite far, I'm getting a range of 12,417.26 yards on a bearing of 153 degrees. But if I want to make that a little bit more precise, of course, I can zoom in and then I can redo it. And now I'm getting 12,411.88 and about 153, 154 degrees. If I release the mouse button, you'll notice in the status bar at the bottom that measured range and bearing is still there. The position will change because that's recording where my mouse cursor is at this present moment in time. So I'll measure this range again. We can see it in the status bar. It isn't just tracks that can be plotted, as you can also plot other objects, such as tracking the proximity of multiple vessels to a fixed point, such as a sensor. And to do this, I'm going to click on Fit to Window, and then I'm going to zoom in around about the 1100 hours position, and I'm going to add a label to the plot. So I come up to the main toolbar, and I click on Label, and I'm going to add it to Miscellaneous. Click on OK, and if I look in the outline view, I can see blank label. Now I'm going to Fit to Window, and here I can see it in the center of the screen. I'll just change the color of it to make it a little bit more visible. There we go. It's still in the Properties view. I'm going to click on Label, and I'm going to change this to Sensor 1. There we go. I'll now move the sensor to a new position. So you can press Alt-3 on your keyboard, or you can click on the Drag Hole Feature option on the main toolbar, and then the cursor will change to a brown hand. I'm going to move the mouse cursor over the Sensor 1 label, and as soon as it's over a hotspot, which means I can actually do something with the object, it will change to a green hand cursor. And I'm going to drag it up near where the vessel positions are at 1100 hours. There we go. Now in the outline view, I'm going to click on Sensor 1, then I'm going to Control click on Collingwood and Nelson, then I'm going to right click again and select View XY Plot. I want the range again. But my primary track this time is going to be my sensor. So click on OK, and now we can see I have another plot tab in the range view time plot area, this time showing the proximity of both Collingwood and Nelson to the sensor. So as we can see, if I move the time slider back to the beginning of this exercise at 0800, that's where they are in relation to the sensor. So that's approximately 12, just under 13,000 yards to Collingwood, which as we can see here on the range view time plot, it's saying around 13,000 yards. And as we can see the progress of the exercise, and then just about 10:23 by the look of it, become 1500 yards of the sensor. In the next video, we're going to look at narrative data.